There are roughly 5,500 species of mammals on Earth. Every single one of them produces milk. So when early humans figured out that you could drink the milk of another species, which is, if you think about it for a moment, a genuinely strange idea, they had an extraordinary number of options to choose from. Bears produce milk. Hippos produce milk. Elephants produce milk. Horses, camels, reindeer, yaks, water buffalo, all of them produce milk, and all of them have, at various points in human history, been milked by someone somewhere. So why did the cow win? Why, out of 5,500 possible candidates, did one specific animal become so dominant in global dairy production that today there are approximately 1 billion cattle on Earth, making the domestic cow the most numerous large mammal on the planet after humans? The answer involves evolutionary biology, agricultural economics, ancient geography, human gut chemistry, and one of the most important genetic mutations in the last 10,000 years of human history. And it is a far more interesting story than most people realize. To understand why cows became the dominant dairy animal, you first need to understand the starting point, which is that for most of human existence, drinking milk after infancy was biologically impossible. All mammals produce lactase, the enzyme that allows the body to digest lactose, the primary sugar in milk. But in the vast majority of mammals, including the vast majority of early humans, lactase production stops naturally after weaning, after the period in early life when milk is the primary food source. After that, consuming significant quantities of milk causes digestive discomfort, something that today affects a significant proportion of the global adult population. Lactose intolerance is not a condition. It is the biological default state for adult mammals. The ability to digest lactose into adulthood, what geneticists call lactase persistence, is a mutation, a specific genetic variant that keeps lactase production active throughout adult life, rather than switching it off after childhood. This mutation appears to have first emerged in human populations in Europe and parts of East Africa somewhere between 5,000 and 10,000 years ago, and it spread remarkably rapidly through those populations compared to the typical rate of genetic change. This suggests it provided an enormous survival advantage. People who could digest milk as adults had access to a rich, calorie-dense, protein-rich food source year-round, including during famines and lean seasons when other food was scarce. But here is the crucial point. Before this mutation existed, and for populations that still do not carry it, ancient humans were still using dairy animals. They were not drinking fresh liquid milk, they were fermenting it. Fermentation of milk, producing yogurt, cheese, and other cultured dairy products, breaks down most of the lactose through bacterial action, making the resulting product digestible even for people without the lactase persistence mutation. Archaeological evidence of milk fat residues on ancient pottery fragments, found at sites in Europe and the Near East, dating to around 7,000 years ago, shows that ancient humans were processing and fermenting dairy products long before lactase persistence became widespread. Fermented dairy came first. The ability to drink fresh milk as adults developed later, possibly partly driven by the advantage of being able to access the nutritional benefits of milk in its most immediate form. So why, among all the animals that produce milk, did cows emerge as the primary choice? The answer comes down to a combination of factors that, taken together, made the domestic cow almost uniquely well-suited to human agricultural life, a combination no other single animal could fully match. The first factor is yield. Cows produce an extraordinary volume of milk relative to their body weight and relative to what they require as feed input. A modern dairy cow can produce 8,000 to 10,000 liters of milk per year. Even ancient cattle breeds, before centuries of selective breeding for dairy production, would have been producing milk volumes that significantly exceeded other commonly domesticated farm animals. A goat produces roughly 1,000 liters per year. A sheep produces around 200 to 400 liters. A cow's milk output, even in antiquity, was in a completely different category from the alternatives. The second factor is size and caloric return. A cow is a large animal. When a dairy animal reached the end of its productive life, it provided an enormous quantity of meat and useful materials. hide, bone, sinew, that represented a significant return on the investment of years of feeding and caring for it. This dual utility, ongoing dairy production throughout its life, followed by a substantial meat and material return at the end, made the cow an extraordinarily efficient investment compared to smaller dairy animals that provided less of everything. The third factor is temperament and trainability. Domestic cattle, particularly the breeds that were developed from the ancient wild aurochs across Europe and Asia, proved significantly more manageable in agricultural settings than many larger alternative dairy animals. Elephants produce milk, but they are not domesticable in the agricultural sense. They cannot be economically bred in captivity and require vast ranges. Hippos produce milk in significant quantities, but working with hippos in any domestic context is extraordinarily dangerous. Camels, yaks, and water buffalo are all domesticated and milked in various parts of the world today, but they are specialized for specific regional environments in ways that limited their global spread. The fourth factor is feed efficiency and adaptability. Cattle are ruminants, animals with a specialized digestive system that allows them to extract nutrition from grass and other plant material that humans cannot eat. A cow converts material that has no direct food value to humans into high-quality protein and fat, and cattle breeds developed the ability to thrive across a remarkably wide range of climates and terrain types, from the cool grasslands of northern Europe to the warmer agricultural zones of the Near East, South Asia, and eventually, through human movement and trade, across virtually every inhabited continent. The geographic story of how cattle became the global dairy standard is also deeply tied to where agriculture itself developed and spread. The Near East, the region spanning modern-day Turkey, Iran, and surrounding areas, is where cattle were first domesticated from wild aurochs approximately 10,000 years ago. This is also the same region where the agricultural revolution began, where wheat and barley cultivation first emerged, and where the first settled farming communities developed. Cattle, wheat, and barley developed together as a package, the foundation of the Near Eastern agricultural complex that subsequently spread across Europe, Central Asia, and North Africa over the following several thousand years. As this agricultural package spread, cattle traveled with it. Communities that adopted wheat and barley farming also adopted cattle, because the two practices complemented each other perfectly. Cattle could be fed on crop residues and grazed land that was unsuitable for cultivation. Cattle manure fertilized crop fields. Cattle could be used as draft animals to pull plows, dramatically increasing the area a farming community could cultivate. And cattle provided dairy products that added a rich and reliable nutritional supplement to a grain-based diet, was often nutritionally narrower than the diverse hunter-gatherer diet it was replacing. The package deal of cattle plus grain farming was so productive and so mutually reinforcing that it spread more rapidly and more completely across Eurasia than almost any other agricultural innovation in the archaeological record. Other regions of the world developed their own dairy traditions using locally domesticated animals, and these traditions survive and thrive to this day, serving as a reminder that the cow's global dominance is partly a story of geographic spread rather than absolute superiority. In the high-altitude regions of the Tibetan Plateau and the Himalayas, the yak became the primary dairy animal, perfectly adapted to cold temperatures and extreme altitude where domestic cattle cannot survive. Yak milk is significantly richer in fat than cow milk, providing extra caloric density suited to the demands of life at high altitude. In the arid regions of Central Asia and the Arabian Peninsula, camels became essential dairy animals, extraordinarily well adapted to survive on minimal water, across vast, dry distances, and producing milk that remains liquid and usable in conditions where cow milk would spoil rapidly. In the Arctic regions of northern Europe and Siberia, reindeer herding peoples developed dairy traditions around reindeer milk, which is among the richest and most calorie-dense milk produced by any domesticated animal. Each of these animals became dominant in their specific region for the same fundamental reason cattle became dominant globally. They were the best available combination of milk yield, manageable temperament, environmental adaptability, and additional utility for the specific conditions of that region. The cow did not win because it was perfect everywhere. It won because it was well suited enough to an extremely wide range of environments, and because it developed alongside the agricultural package that happened to spread most widely across the ancient world. Here is what all of this adds up to. Humans chose cows for milk production, to the extraordinary degree that cows now dominate global dairy, because of a combination of genuinely superior milk yield compared to alternatives, remarkable dual utility as both dairy and meat animals, a temperament and size suited to agricultural life, feed efficiency based on ruminant digestion of grass and crop residue, that cattle were domesticated in the same place and at the same time as the agricultural revolution that subsequently spread across most of the ancient world's most productive land. No other single animal matched all of those factors simultaneously across such a wide range of environments. And so, the cow became, over 10,000 years of accumulated human agricultural history, not just the dominant dairy animal, but one of the most consequential animals in the entire history of human civilization. All 1 billion of them, standing in fields around the world, descended from a wild animal that some ancient human in the Near East 10,000 years ago decided seemed worth taming. If this gave you a new appreciation for what is in your morning glass, subscribe and leave a comment below.